Yeah. Okay, so
you stink, Sander.
This is Sharon Smith and Perry Reed. Sharon is my wife, Perry is my coworker, and we may have Valerie, Corey's mom, joining us. She said she was going to.
And Corey join us.
So I asked you guys to come up with questions, and Jalen has questions.
4.
Hopefully the rest of you can think of questions, but if they, no matter what they ask, answer with a view towards improving how we learn to write code.
Oh.
Okay? So go ahead, guys, ask questions. Don't touch the camera.
I want to look at it.
I said don't touch the camera. Okay, go ahead.
I'm not going first.
Me either.
Xander, you.
Right? Since you came up with it first.
No. No. Xander. No.
I pick Jalen.
What? No.
Questions are easy. It's harder to do the answers.
You, Xander.
Xander.
No, Jalen.
Xander, you got it
Okay, I'm going to think of a number from 1 to 10. Whoever guesses it is going to go first. Guess a number from 1 to 10.
Don't guess 10.
Nope.
7.
Nope.
90.
5.
Nope. And that was 9. Guess again.
0.
That's not from 1 to 10.
You said 90.
That's 9.
I said 9.
Hurry up. All right, I think you go first.
Okay, it's 7.
No, you already guessed 7. Guess a different one.
I guess 8. Okay, 8.
No.
6.
6. Guys, you're first.
Ha ha. Wait, so can you repeat the question because I lost track?
You make the questions.
What about the code writing?
Yeah, code writing.
Okay, so look at my question. See?
Hey, my spot.
Fine. Like that one.
Go ahead.
Okay, so is there like a specific? No. So does each different coding element have different language?
It's a really good question. You go first?
Like as in between Java and what you said?
Well, there are many different languages, and they're basically, on the inside they're the same, the coding itself is the same, but the way we use it, just like English versus some other language,
Spanish.
or Spanish,
Or France or Japan or China.
yeah, that part of it might be a little different, but the message is still the same. Just like if you say hello in English, and you say hola in Spanish, the message is the same. So yeah, there are many different languages to program in, but you can still do the same things with it.
Right.
Is that a good
I
answer?
have a question. How do we activate it to get our codes? How do we activate it to get our codes?
Activate what?
Just press enter.
Usually we click a button or do something else, like open up a program. It's called an event. Okay, so there's many different events you can do. Can you picture going on the internet? You do lots of different events. What do you do when you want to go somewhere on the internet? Because the internet is a big program.
Roblox.
What do you do?
Roblox.
No, what do you do with your mouse? How do you tell the computer to do anything?
I just move the mouse randomly around.
So if I go like this with my mouse, I'm going to get places.
On the mouse pad.
If I go like this with my mouse, stuff is going to happen when I'm online.
Technically, yes, but
Stuff is going to happen if I do this with my mouse when I'm online.
right,
What's going to happen?
it's basically gonna turn the camera and do it this.
Yeah, the mouse is going to move around, but that's it.
You have to navigate it to what you're going to click.
Okay, so I move into what I'm going to do. What?
Click.
Oh, I click.
So
You
say
can
you
do
want to
this
exit
video.
the icon that you're at, you just move the mouse and click where
You click. It's the clicking, right? So the clicking is telling the computer to do something, so that's how you activate your code, by clicking. Or by doing other things, by hitting enter, whatever you said, enter.
All right, I'm going to jump in and ask a question so we can focus a little more. Did you learn how to write code, and how do you think it would have been better for you to learn how to write code?
These are my questions.
Okay, Jalen can ask the question.
No.
We're gonna have
So let's go this way. Sharon, Perry, then Valerie. How did you learn how to write code? And
Another question though?
And also like,
Don't worry, it's just the time is up. Based on Lewis's question, I was wondering if he knows what code is, because he just joined our team on Saturday.
Yeah, that's what I told Dave. I think he has no idea what we're saying.
Because he didn't, by the time he joined the team,
we had already picked the
the
project.
topic was already picked.
Right.
So writing computer code, if I'm not mistaken, is writing a sentence about what you want to have appear on the
It
screen.
makes everything
And
happen.
then when you publish it, I think, it actually looks like that. So somebody had to write the word Roblox, tell it how to look, so it looks like it's 3D or whatever, and then when they put it where it's supposed to be, then it looks like that. Am I
Like
correct?
games that have to have a lot of.
So actually, how to make Roblox be Roblox is what the kind of stuff that they do. Get it? And that's what code is. So,
Code is what makes Roblox.
right.
No.
No?
Code is what makes robots move and do things, but it doesn't make the robot. Legos make the robot.
No, Roblox. Like
Roblox.
it's a game, computer game.
Oh. Oh, yeah. Pretend robots, you mean, on the screen?
No, road blocks.
Road.
no, it's roadblocks is
Isn't that what you said, road
Kind
blocks?
of like Minecraft.
No, it's
Automobile
roadblocks, but
fence.
instead if you use someone else's, you can't do anything.
What?
Like if you have like a friend, you can't visit anything.
Okay, well,
You
let's
can't,
move
like,
on anyway.
Let's just say if you.
Why don't you answer the question I asked one at a time?
Yeah, okay.
How did you learn how to write code? And how do you think it would have been better for you to learn how to write code?
You guys start. I'm still thinking. How do you forgotten?
Okay, I'll start. I actually had gone to school and started in college, taking computer science courses, and I started learning code, taking, I believe it was C++ first and then Java. And I think it would have been better had I experimented on my own, because in college it was very clinical and it was like by the book. And although it was very helpful, I think learning it on my own and just experimenting with the language that I may have been comfortable with at first, maybe something a little easier than a C-based or a C++, it would have helped me a lot. Or at least allowed me to get better faster.
If you guys have follow-up questions or want to jump in, like a follow-up question might be like,
Was it hard?
sure.
Yes, initially C++ was very hard because it's like learning a whole different language.
Good to know.
Yes.
So it's almost like me, Lizzie, remember how that last year, exactly a year ago or so, I was like a beginner at Scratch?
Oh, right, yes.
You know how that most of that stuff I learned myself? It's kind of like that. Right? So I pretty much know what Valerie's saying.
Okay, so you started at scratch, like basically not knowing anything about it and experimenting on your own how
Yes.
to get better.
And then right now I'm moving on to Java, which is where the code writing came out as a project.
Actually,
That's
I
good.
was wrong. Can I ask?
Yes.
I was thinking when you said, Valerie,
Yeah, either.
when you said you wished you could have experimented on your own, what would you have done with Java on your own, and how would that apply so that you could use it on your own? In what context?
Well, I probably would have maybe picked up a book at the library or something that explained how to probably create a game, because at that, I think I was like 18 or something, many years ago. And like doing it for, and starting in college doing C++, you're doing these text-based projects that sometimes you see that there's no ground. It's just a project, a theoretical, database or
So
something.
you can't really see a finished product?
Exactly. I mean, you see the product, but it doesn't, for a kid, it would be much better to see something moving on the screen. Like I wrote this code and now this block moves from this point to this point.
What's the program called?
What program?
Like to
Learn how to write code.
Well, when you turn your computer on, usually you have Windows, is what comes up. Is that what comes up on your computer at home? That is code that Microsoft wrote so you can run your computer. Every time you click on an icon on your desktop, do you know how you click on an icon when you want to go to a program, even if you want to go to like the internet? Every time you click on something like that, it runs another program, like internet program, whatever one that you're picking. So every time you see a little icon and you click on it, it runs a different program. And every one of those different programs are sometimes in the same language, but sometimes in different languages. Does that make sense?
So Perry, why don't you give us your answer to the original question?
Let's see, the original question was, where did I learn it?
How did you, or how or where did you learn it? And then how could you have been better for you, a better way for you to have learned it?
Well, when I first did the programming, it would have been in high school. And it was on a platform called NC, not CNC, which is numerical control. And it's a piece of manufacturing equipment, machinery. And that particular machine drilled holes. So I had to tell it where to go and when to drill. And that was my first exposure. So my world is a little more physical. I make machines go. And from that, I was, once I got out into the workforce, I did go to college for 2 years. I did take some programming in college, not a whole heck of a lot. And then once I got out into the real world, I was factory trained. So that's where I learned other languages and other things. So I learned how to program robots, but not the robots you guys are familiar with. And I learned how to program machinery to move and do some sort of task. How could I have been better at it? I think it would have been better for me, actually the opposite of you, to get a little bit better grounded in a lot more of the background to the language before I progressed into actually making things crash into each other. So I'm pretty good at that.
So you got too much hands-on.
Too much in the
And Valerie, you got not enough hands-on.
And one thing that, and I'll say this is, and I think I mentioned this to you more than once, is right early on I was overconfident. So I was a lot like the kids probably are right now. I'm going to make this do this. So when you do that with machinery, things happen. It's not always good. Things crash and break. So to have a little bit better background, I think a more scientific approach is probably a good way for me to start.
So Barry. It's, yes. And so it's almost like it's that your brain tells your arm to move 91, or like let's say 100 degrees, and you really wanted it to move 90. It would basically like it.
That's exactly right.
So you're saying that one slip up could cause a big error.
Big, huge.
Almost like a slip up in, as you mentioned, OS test. Right?
If you say, if you have this object and you say, I want to move it 90 degrees, and 90 degrees is here, but I put in 100, and the say for instance a table, it's going to crash right through the table. So that's the real way.
Table.
Yes.
Louis, before you ask your question, Perry, maybe you could share with us the biggest crash that you made with your programs.
That was so many. I didn't crash the machine tool. I've only crashed robots, which are considered machine tools, but we won't get into that today. Probably crashing through a demo room window was probably the worst event that I created. And it was basically doing exactly what we just talked about. I wanted to go someplace I didn't really want to. Putting a number in that was too big and greater than the number I wanted. So I crashed it right through the window and it was a demo room about this size. It was pretty embarrassing. But that's really the worst one. Last one flying down 2 stories after the parking lot.
Trinity, do you know what question you want to ask? Melissa's still thinking. What's your question? Go ahead, yell it out.
How do you guys improve learning without coding? Well, that's
already
what
been
we're
asked.
trying to do.
Have we improved? Have we improved?
Oh, that's different.
Oh, yes. I think every time you, so here's what happened. No, you guys want to answer that? Well, first of all, I was maybe a mix of them. I got a job as a programmer, and I didn't know how to program. And I don't know how I got this job. So they stuck me on my job, and they said, write a program. So I kind of wrote it using another program, and they said, no, you have to write it in its own program. And I said, I don't know how to do that. So I ran to the bookstore, and I got a book, and I read the book, and the book told me step by step what to do, and I still couldn't get it to work. Well, I could get some things to work, but then I had to ask a lot of people to help me. And I had to keep asking for help and asking for help. And then eventually the internet came out, and I could ask the internet for help. So, but improving, like what Trinity asked, if you look at the first program I wrote, it was a total disaster. It was a mess, and it was just not a good program. If you look at the second and third program I wrote, they were a mess. They were very bad. You probably never should have sold them. But if you look at like the 5th, 10th, 20th program I wrote, every time I did it, I got better and better and better because I kept practicing and I kept learning more. So I started out knowing nothing, and then I knew a little bit more, and then I knew a little bit more, and a little bit more after that. But the places I went to get help were, I went to my book, I went to help because every program has a help screen. And then I went to the internet and I asked other people. And I think asking other people who knew how to program was one of the best things I did because they could show me. So those were the 4 biggest ways I think I learned. And plus I learned from my mistake. Because when you're coding, it's just like you guys when you have a robot. You want the robot to do this, and then this, and then this, and then this. If the robot misses one of those steps, it's not going to keep doing what you want it to do. So it's the same thing when you're writing code. You follow your code and you say, okay, my code did this, and then I wanted it to do this, but it didn't do this. But it did the next step, so my code actually ended up doing this, and then this, and that's not what I wanted to do. So I have to look at exactly where my error was, and I have to go fix it and make it do the right thing I want to do. So if I have a robot that wants to go this way, then this way, I have to see where the mistake is first. And code is very, very specific with its mistakes. Because as soon as it makes a mistake, if you don't go back and fix right where the mistake was, you're not going to get to where you want to go. No. Not at all.
Might be close.
Yeah. Or you might have an arm smashed through a table, you know?
Or we haven't heard anything from you yet.
Did you remember your question?
I have a question for you. How do you improve your environment?
How do I improve my environment? What environment? What do you mean?
How do you know
You mean how did I make it go back to where it went years ago? I asked people questions. I had other people come look at it. Like you guys have a team, so I would ask other people on my team if they knew where I was going wrong. And so they could sometimes help me. Or I would Google it. And maybe all the other people out there that I don't know that aren't on my team, but other people who have done it before, they can tell me where I went wrong too. Or sometimes I would walk away from it and do something else, and then when I came back, I would have new ideas.
Jalen, what are some of the questions on your paper?
Yes, because Corey, I already did one. Yes, because we haven't heard
Any
anything.
questions, Corey?
What's the
hardest part about coding?
That's a good question.
That's a really good question. We probably could all treat it.
I'd say finding the bugs. Once the code is ready and you go to compile and see and expecting it to run, and then you get these errors. You have to find out where the error is and why it's what the error is and fix it.
Especially for parents.
Yes.
some of the errors can just be as simple as like a parentheses or comma.
Yes, yes, actually, there was when I was in college, and it was one of my maybe third or fourth assignments, and it was about, wound up being like 10 pages of code, and it was just all code, and I ran it, and there was an error, and I couldn't find it, and the professor wasn't going to help me because he wanted me to figure it out. And I'm like, it's maybe 11 o'clock at night, and I'm like at the computer with my eyes crossed, like, what is wrong? It turned out to be like one semicolon at the end of the line that was missing.
And how many hours did it take you to find the semicolon?
Like maybe 3 or 4.
Okay, Trinity. I was just going to say that, Trinity, do you remember that one day I was sitting in front of my code?
Yes.
And I was trying to get it to work and it was missing one quote.
I know.
Are you guys really detailed? Can you look really, really close if you're missing 2 quotes? Are you good at proofreading? Like, you know how you can tell there's spelling errors in a sentence?
I don't enjoy it.
You don't enjoy it? Well, you have to do it as a coder. I don't think any of us enjoy it, but you spend so much time working on your program that you want it to work.
So this is a question for all of you. Say what inspired you of your career.
That's my question, Sam.
Oh, yeah. For all of you.
I get to start. You know, sometimes it's like when you're interested in something. Like some kids like sports, some kids like cars. I was always a car guy. But you get inspired sometimes because when you go to do something, you just really enjoy it. And that's how it was with me. When I was in school, I had good teachers first of all, and I think that helps a lot. But when my teacher wanted me to program that CNC machine, that was brand new for me. And it was just something I, right off the bat, really wanted to do. When I first saw it move, that was probably my biggest inspiration. Because I knew I made it move.
So, do you think that perhaps that you could combine your career of coding with your liking of vehicles? Like perhaps program, let's say, a machine that had a automatically repair.
Are you asking if I could do it? Not quite.
No, I'm saying that you could combine your career with your favorite liking.
Yeah, I could. Right now, I think when I play with my cars and stuff, I don't really want to do anything.
Valerie?
Play with my car.
Well, I'd say my love for computers, I guess, started from web design and web design, and it was around the time when web pages were like this big thing, and so I really wanted to learn how to do it. I think I developed a web page for a small company that was just starting out on my street, and I loved doing that, and I think that was what inspired me to actually want to delve more into the coding part and learn other languages and things like that.
So, do you mean stuff like HTML?
Yes.
See, last year we had a woman named Kendra who looks a little like her. She used to teach HTML right over there. And finally,
Because I like puzzles, and so I really like finding out why things work and why things don't work. And when you're coding, you're really trying to make something work. So you have a picture of what you want at the end, kind of like you guys when you have your challenges at the end, and you know you need to get there, but you're only here, and you have to somehow figure out how to get there. And that's what seems like a big
so
puzzle.
it's almost like we used to do it.
Yeah, right. But yeah, it's a big puzzle, and I like that the puzzle, it doesn't necessarily have one right answer, but you know when you're right, because it actually does what you need it to do. Jalen, I'm dying to know what's on that paper.
He took one of them.
Oh, that's fine.
It took number 2, which is the inspiration, but I agree. much do you get paid hourly?
Oh, I think it depends on how long you've been doing it.
No, I meant like hourly.
Right. Well, usually there's salaries. You get paid for the job. You know.
I have a question for you guys to answer.
It depends on how many years you were working. Hold on 1 second. It depends on how many years you've been working. So if you've been working for 1 year, you probably won't make as much. But if you've been coding for like 15, 20 years, you'll probably make a lot more than a decent amount of money.
I'm in. Which is why I also asked for it.
What was your question, Trinity?
My first question is, what kind of it?
Oh. I
You
don't know.
have a question about code grading?
Or no?
Yes, that's my second question.
Ask it.
What's your question about code grading?
My second question is, do you guys like coding?
Oh, you must have learned for that one. Yes.
I like it. Absolutely.
So it takes a lot of time.
It does, but it really is pretty rewarding.
Do you guys ever do math? And it's really hard math?
Yes.
And at the end you're right? How do you feel when you're right at the end of your math?
I like it.
Do you like that?
Yes.
How do you feel when you're wrong at the end of your math and you put down the time? That's what it feels like to be a coder.
Okay, so you'll be like, okay, so I got this part wrong, so I'll go back, erase, and then write the correct answer. Correct it?
Yeah, so you feel really, really, really good when you got the right answer?
Yes.
And you feel really, really, really bad and you feel like you wasted your time when you did the wrong answer, right?
Yeah.
Yes.
When an error occurs.
Yes.
I wasted my time waiting on me.
But did you waste your time when you get things wrong? Was it a waste of time? Why?
Feels like it.
Do you learn what you did wrong and not do that again? So that's not really a waste of time.
I kind of do that for the teacher.
Isn't it supposed to be interviews the adults, not the kids? And you still haven't answered my question, what time is it?
Oh, we don't know.
It's quarter of.
You can look at the clock right there. You don't need
Start ready
to.
to get a watch.
Meaning 5:45. Or 5:44.
Lucy has questions.
Actually, I was wondering if you could tell all of us where you worked out, how long you've been working in computers.
You guys go first. You probably don't know programs.
Well, I actually work in an elementary school. I don't work in computers. No, I do jobs in. I do computer team projects. Now more like freelance. And I've been doing that probably for maybe 6-7 years.
So you work for yourself, basically?
Well, yes, when I do projects, that's pretty much, yeah, that freelance is pretty much like self-employment, I guess. But my career is in education right now, and I'm actually pushing towards computer science education. To teach that.
So you're going to teach computer science in what grade?
Probably, I really want to push for it in elementary, but it will probably be more for middle and high.
Yep.
Perhaps that you could teach our tech ed class at Orange Middle School. No.
We'll get to it.
You know, the old high school? Where it used to be the fish ripper? They're in school way too long. But I like being in school that long.
How long are you in school?
7. Well, see, I have to get there. I think he's in like an extra hour.
Okay.
And I get out at 3:45.
Wow, that is a
My
lot.
stupid son.
But awesome.
Wow.
I get out at 1:50, but I go in at like 7:30.
So Perry and Sharon, you didn't get to answer Lucy's question.
Well, I've been at Avery Dennison now 3.5 years as a manufacturer. But my focus has been in machine controls for 30 years. 30 years? So I don't know, something like that. I lose count. But I really enjoy coding, but for me, a question that I would ask you kids is, why do we call it coding? You guys know why we call it code?
Isn't it another one for programs?
It is. It is.
We put codes because we call it coding because you can put in a tons of codes.
Hi, Sandra.
Alright, so yay! Thank you all genuinely much for coming.
Well, thank you for such great questions. So, Louis, you're pretty much set because with the programming, you're giving commands or codes. So we call it coding. And those languages, those codes might be a little bit different, but the logic of the message is the same. Your turn.
I worked for 8 years at the beginning when the internet was getting really big. So that was fun. And then I went to education with you. I stay at home with my kids now, and I just do a little on the side. I just manage a website now. I've been doing that for the last 3 years. But I did a lot in the middle, too. But I can definitely tell, you guys are asking to learn how to code. One thing I noticed is that you never stop learning how to code because it keeps changing. It's constantly changing. My skills that I had, I know the basics of like how to learn, and I still need to keep knowing how to learn how to code because it changes and it keeps changing and it keeps changing. And if I want to make money and I want to keep making money, I need to up my skills and I need to keep learning the newer languages because the older language and some of the other stuff that I've written now, which I'm really good at, it's not as fast as the new stuff. So if I really go back into coding, I'm going to have to relearn a lot too. So which means I'm going to have to go home and practice and ask questions and go on the internet and get a book and do all those things all over again and just do a lot of trial and error, practicing and failing and figuring out what I did wrong. So I think that is, your question again is how to learn, right? How do you learn how to code? I would say those 4 things, if you guys want to write those down, those would be the 4 biggest things. Research and asking questions and failing and learning from what you fail at.
Mom,
But
by the way, would you still coder?
yes.
This is for all of you. Are you still coders?
Yes. I coded for Perry a couple years ago.
Yes, you did.
I don't know if he uses it, but yeah. That was fun.
Did you repeat those stories actually?
Oh yeah, I will. The 4 things I said is research, and when you do research, you ask other people, or you can research on the internet. So that would be 2 researching, or in a book. That would be 3 ways to research. Another way would be to ask other people. Another way would be to try it yourself and fail and figure out where you went wrong.
And Louis, that's what you did this past Saturday with the Lego programming. Remember, you watched that guy on the YouTube video make the robot go on a square, right? And then I said, see if you can do the same thing. And the first thing you did is you had the robot go and stop, right? And then you had him go like this in a big curve. And eventually you got him to go in a line and turn, right? Yeah, so you did trial and error, what Sharon just said. And you learned a lot just by trying it yourself and failing, didn't you?
But don't be afraid to fail. If your robot goes and it misses its goal, that's okay, because that's part of the learning part. You just have to figure out where it went wrong.
I failed like 50 times.
And that is fine. Do you guys know that
engineering test?
every great scientist out there has failed way more things than he's done really well at? We just remember the things they do really well at. But if you were to talk to like Edison, when he made the light bulb, he had so many failures before that happened, but he didn't give up. And you have to not give up. You have to take the attitude of, I am going to win and I'm going to beat it. And I'm going to win. Either the robot is going to beat you, or you're going to beat the robot and make it do what you want. Which one's it going to be? Do you want to win? Or do you want the robot to
Are
be
you going to let the robot missions win, or are you going to win? That's the question you're constantly asking. Well,
You
if
wanna
you're going to win, you have to fight for it.
Yeah. You know how they have sports and sports teams are always like competing against each other and they're really, really competitive and you can see them both? It's the same thing when you're dealing with science and coding and robot. The computer's going to win or I'm going to win. There's only going to be one winner in the end. So either you're going to master over it and tell it what to do.
It's funny you use this analogy because that's exactly what I say when I get it right. I sit right there and go, I won. I've been doing it for a lot of years.
I have another question too, guys, and this is, see if you think this is a good question. So, there are a lot of new ways to learn, and I really like the way you said you have to learn how to learn to code, because you all said you wish you had done it differently. But there's so many ways to learn things that my daughter is really having a hard time with. And that's right now, everyone's saying, go on Khan Academy, go on here, go on there, and different websites and stuff. So, is there a way that we can think about that will help people learn how to code, or learn how to learn how to code, or how can we make that better for people who don't know anything about coding, like you guys want to say?
The baby steps. How do we do the baby steps?
Oh, I think about this with Trinity and Torah all the time because I know a lot of how to code, but I want my kids to know how to code. And I think you guys are lucky because you are part of the generation where if you start learning the code when you're young, you're going to be the first ones to where a lot of you are learning when you're young. And that's kind of what we want to go into is the education for kids. But I think about it with Trinity and Torah. I want them to learn how to code. And starting next year, I'm looking at different options, and there's not a lot out there. So one site that we learned about when we were here was code.org. Have you guys ever been on that website? If you go to code.org, Trinity, you and Torah have been on it. You can learn how to make games. It's like a baby step to getting you to start coding. And they're the ones, code.org is actually the organization that's trying to put more computer learning in schools. So, yay for them. But I would start there.
Start where? What was it?
Code.org.
Code.org.
I already finished that.
You did?
Yeah.
So now you need to go somewhere else?
So on code.org, you're actually typing in text commands?
No. Well,
No.
it's drag and drop. It's kind of like what you guys do with the Lego robot program, right?
Yeah,
Is it drag and drop?
so
Would you can build logic in it?
Yeah.
So with Mindstorms, just so you guys know, with Lego Mindstorms, the programming language is very block-oriented and it's sequence-oriented. So there's basically like a play, like the triangle for a play button on a tape deck, you know? And that's the start, and then you just drag blocks onto that, and it goes in that order. And you can create loops, and you can create decision blocks. And so the logic's there, but I guess I'm wondering, how would they transition from this simplified block type programming? How would they make that next step to writing text?
Writing it in words?
Yeah, words.
I think it's a huge difference because I was looking at the Mindstorms programming and like the logic is the same,
Yeah.
but for them to understand the while loop and actual writing it and if then else and all of that, as opposed to this block doing making the physical loop. I think it depends on each kid needs to understand their learning style, and some can take a visual and be able to translate it easily into those texts. If the robot does this, then if it hits the wall, then we're going to do this and that. So and then some can, if you want to transition into just regular text code, some can just take a book and read, and I know that some kids learn better that way. So each child's style of learning is different. Some need to see it visualized and need to be able to look at the Mindstorms versus the text and compare the two and say, oh, this loop here means that I'm writing this here, while some can just take a book and read it and learn that way.
So maybe there needs to be a tool out there that translates from the visual to the textual.
And there is
Like you're saying, like this is the Lego Mindstorms, and this was what it would look like in text, like a translator almost.
Well, actually, that's kind of how I learned how to write macros in Excel. And it's also how I learned how to program. You know how I told you I used a program, but I couldn't write myself? That's when I got my job, I thought I was going to get fired. But I found a way to go and record the things I want to do. And then there was a button I could push that said convert it to code. So I could go out and do the things I wanted it to do, and then I could see how it wrote what I wanted to do. And when I could see what the words were that they used, then I started understanding a little bit more how to go from the picture and the idea to the actual words.
Yeah, so you got the same thing. You saw the actions visually, and there was a translator that helped you figure out what the text version of that was.
Yes, and that's saved use.
Perry, did you have any experience like that, where there was a visual that you had? Like you actually were working with machines that moved, so the visual was kind of like through your trial and error, right?
Yeah, it was a little more tactile, but the thing is, we still, there are manual methods to do the exact same thing. Flowchart is a good example. So if you wanted to create a sequence of operations, you do it in a flowchart, and that flowchart actually breaks down that imagery. As you do it, it's the same thing. It's very manual. It's not like today's one. You write out a flowchart that says, and you have a decision block, which is usually a document, right? And it says, you know, if this input is true, we're going to do this. If not, we're going to do that. It's very easy to convert that into a textual based decision. If this, then so on and so forth. That's how I think it over the years. I don't use a lot of that.
Okay, so Corey, you get to have the last question because we're out of time, okay? So your question is the last one.
Where do you get your
Where do we get what?
They give you the job and then they use it on stuff and then they get money.
Oh, you mean when we're done coding, what happens to it? Yeah, your Jalen's right.
They send it to the company that paid them to do it and then they get their money.
Yeah.
That's a good way to conclude, right?
Yeah.
You give them your code, and then you get your money.
Now, coding is all about breaking down.
Yes.
That's what we need right there.
All right. Thank you.